Oh, no.
Just started recording.
I've turned off my options. Right, first I need to scope online, so let's do that. Okay, so now you can see what I'm doing. I can see. Right, this little device. This is the this is actually a microscope, a very high quality one, and it's aimed at the coil. And there's not enough light, so if I whack the light up, right now you can see the tube in the coil.
Yeah, that's it.
I'll just get it stable, right? It's pretty well focused, right? You see, one of my temperature probes has actually come off when I had an accident. Oh God, I've been called again. Who's it? Oh, it's probably Chris, Steve. Yeah. Yeah. Well, I did tell you I had to bail because I've got to go and talk to Chris. Yes, probably. That's one of the carers. Well, you carry on with what you're doing. I'll catch up with you later because I'm explaining to Chris now, but setting up the ionizer. Oh no, because you're going to be another hour or so, won't you? All right. No, I'll join you later. All right. All right. Bye. Bad communication. Anyway, and Steve was wondering who was calling him. I said that was you. Right. Okay. No, he's trying to get his film thing running for his mate. Right. Let's try and get the ionizer running because that's the one I want to show you is when we've got it jumping around in the tube. We can get the scope up and running as well, I suppose, because normally I just, when it's on, I leave it on. I'll tell you what, let's leave the scope, but we'll start the spectrum analyzer because once you light this tube up, you can see it. Right, there we go. Now we're ready to light up. Although I will need the scope for the coil. If I want to get the coil running, I need the scope so I can see what voltage I'm running. Right, so let's switch on now. Let's switch on the oscillator. 3, 2, 1. Yes, it stays on. Right, 238 volts, because that's what we've got here. She's showing 234 down there, but yeah. My mains voltage fluctuates up here because of the inverters and all this shit that's going on. Right, so that's on. Now we need the power supply for the ionizer, which is this one up here. It's 15 volt. We'll turn that down to 14 volts because, yeah. That in here. Now I've got to see. Remember, I can't see the oscillator at this point. Just check the wiring first. Yeah. Let's get this power from that black wire. Switch. Actually, power it for a switch. Okay. I think I did. Yes, there it is.
Yeah, I know, yeah.
No. No. Just wondered if it was right. So I had to get the scope on there anyway. The concert is going on now. It's just, no, it's all in there. That is in there. Wire's in there. That one is in there. And that wire is in there. No ionizing. Right, there's my little high voltage. No, no ionizing going on there, but it is storing power, which is weird. So, well, turn that off. Right, so I need the scope now. Oh dear. One of them days, Chris, just nothing is working. Right. I need the scope. Okay. Look it like that. Uh, okay. This one here is just where that happens. This panel here. Is that blue one? Dark blue one. Okay. A bit hanging precariously. Wedge that in there, right? Yeah, because you shouldn't be using half an ampere. It's not producing anything, right? So now I should be able to see the oscillator. You see now it's locked out. The oscillator is locking down. Why? Why is it locking down like that? Okay. About how many volts about? Oh, that should be 50 volts. So it is locked out. Why? Just get the probe out of all this garbage that's around there. Right. You can see the signal coming in.
I got a signal.
Oh, it's a fan. Yeah, there's the signal coming in. It's tiny, but it's there. This is 10 to 1 probe, which we'll check out. So, yeah, the amp suddenly locked up. I don't know why. You need a resistor in there before. Let's just crank that. Channel 5. 5 volts. Right, that's me. This is the oscillator. There it is. amplifier's output down here is staying plus
Yeah.
and plus. It's locked up for some reason. It shouldn't be. What we'll do is we'll turn the voltage right down and switch it on. Switch it back on again. Oh, my washing machine's playing up. Right. It's the amplifier's not working. Ah. Look, it's from the oscillator. More than enough. The amplifier. I think the signal cap has broken a little. Yeah, input cap was loose. Okay, so now I know what that is. Switch it off. Oscillator down to minimum. Okay, how can I get to that quickly? Can I get a soldering iron in here? Ah, and I've glued it. It's actually the glue that probably pushed it back. Oh, I'm gonna need a microscope. Fucking hell, Chris, this is tiny. Okay. So I'm gonna have to solder that. Which means getting an iron over here. Oh, what's stuff to do? Right, let's plug that into the variac. It isn't perfect at this point, but who cares? Right, let's take that heat up. Good means. Yeah, you see this on the microscope, it's tiny. We've got to solder is that bit there. And what? Oh, no, it's not taken. Okay. Let's tin the pad again. Right, there's a gigantic blob of solder on that. I think we're ready to go, Chris. Solder iron out of the way. And then film this here. Plug this back in. Get it oscillating. I think we're ready this time. Everything that could go wrong has been going wrong, Chris. Murphy's thing. Right, there we go. Now let's get back focused on the coil. Like that.
Okay.
Right. Yeah, we can get it oscillating now, I think. Let me see, everything's in place. Let's switch them on. Oh, there it goes.
There it goes.
There it goes. Yeah, you can see the Spectrum camera has picked it up as well, even if we've got lights on there. We'll just turn the lights off. We're going to get ambient. Now, what are the frequency here? You can see the feeding's using to. What are we at now? We're at, oh, we're above 40 kilohertz. That's no good. And it's doing weird things. Now, let's take it down. But if you go to like very high frequencies, you can actually get the plasma to go to the middle of the tube. Now,
what about the other core, the big core? Or something? What current have you got going through it?
Oh, that's very bright. Look at that. Now, I'm not sure what the current is through this. I can adjust it in some way now. And I think that is at the 30 kilohertz mark where I wanted it, 35, 37 kilohertz.
Actually,
How, can you see what's happened now?
yes, it's going down the middle.
It's gone down the middle. And that happens at certain frequencies. And at a certain power level, if you get the power too high, then you can see it jumps around. But I've got a fairly mean plasma there already in the middle, but due to it not being synchronized, what I've found out is that really doesn't help because I thought, oh, I've got it in the middle. You actually want it more like that. I'll put that. Now that light blue one is my inductive pickup. That's an inductive pickup, so that's showing me what's actually going to the tube. The yellow one is the main coil. And even though it's not connected to anything, it's still putting voltage on the coil, just by inductance. So yeah, and you can see we're at 649 nanometers and 432, and some blue in there. But yeah, that changes when the coil's running, obviously. If I get that to, I'll get to its peak like that. Right, and then switch that off. Oh, there's my washing machine in the background. I wonder what's making a bloody noise. Got socks and jumpers going at the moment, so yeah, I can't close the door because there's an antenna cable going through it, so I've got to cut a chunk out of the door. so I can close it properly. So right, we've got our ionizer working again. Oh, I said it's yeah, I need to know what that frequency is now. This is the frequency. I mean, I don't know. It's got to be good. It's got to be about 2,000 volt. I'd like to know what the voltage is. I've got no idea, Chris. And I've got problem is I've got a high voltage current meter, but it's DC. So it's obviously oscillating. I don't see how I can put the meter in there, and diodes aren't going to help. Not at that voltage. I'd need 4 microwave diodes and then put it through the meter. Then it's
All right.
put the 4 microwave diodes back to the. Yeah, I don't see how. No, I can tell you the going on the power consumption. Let me just switch it on and look at the meter. If the meter is wired in. Oh, the meter's not wired in. Right, because the dark blue one now is output an oscillator. Okay. We'll switch that off and we'll ramp that voltage down a bit. 10 to 20 volts. What does that look like? Okay. Very shitty signal though. Okay, we'll put that back up to its 50 volt reading. And so right, we're ready now. Basically, we can do a test firing, I think. Oh yeah, all we've got to do is set up the scope. Hang on. Measure sources, channel 1. Peak. Horizontal frequency. What do we need more? Max. Vertical max. Then we need channel 4. Max, peak to peak. Maximum. And then we need the frequency, which we got, and then we need the current in those 2 probes. So the current in channel 3, expressed in volts in this case. Measure source, channel 3, measure peak to peak. And the input current is channel 6. That takes little gulps from the supply. Measure source, channel 6. Measure vertical maximum. Pretty much else put it as maximum. Oh no, put it as peak to peak. Okay. And it's got other measurements, but that's basically it set up now. No, I have to keep doing this every time I reboot the computer. I've got to do this. So now we can actually fire it up first with coil and all. Bearing in mind that I'm going to run it at lower frequency again. I don't want to kill this transistor. And I haven't tested this wiring here. Can we put? We find out. Quite long. I'll get off. Battery on. Hey, that works. Let's see if we've got power going from our coil now. Take the power out of here. No, we've got no power on that transistor. power from the battery. It's going back to this connection here. And we're going to get very far with this today. Yeah. Right, there it is. That end of the coil goes to the transistor there, and that should see that. Oh, bloody hell. I'll bugger this. I'll have to go with the multimeter first. There, halfway. There. We're going to have to solve all of these, Chris. Again. Shit. Right. We'll have to do this again. Solve it all. Such fine wires. Right, that's not that really wide. Yeah. Let's do this one with the bow.